Hello, in this video, let us discuss solving system of equations using the substitution method. Problem number 1. Solve the following system of equations. We have two linear equations written, and let me copy. Okay, as you can see, I copied the system of equations and I use some color coordination. I use a different color for the variable y, and there's a reason for that. Because for substitution method, the goal here is to focus on one equation and isolate one variable. And you can isolate x or y depending on what you like. But let's say I will isolate the variable y on the first equation. Therefore, this becomes y is equal to transpose 2x to the other side and make it negative. So negative 2x and then plus 7. And the goal here is we will substitute this y since it is already isolated. We will substitute this into the y variable of the other equation below. Let us do that. X, let me copy, x minus 3 times y, and y is equal to negative 2x plus 7. Negative 2x plus 7. And just like that, we already used the substitution method. Equal 0. And as you can notice, the only variable remaining is the variable x. So we just have to solve for x. Negative 3 times negative 2x is positive 6x. Negative 3 times 7, that is negative 21, equals 0. Combine like term. X plus 6x is 7x. And transpose negative 21 to the other side. It becomes positive 21. And if we divide both sides by 7, the value of x is 3. Alright. Take note that the solutions of any system of equations in two variables is always an ordered pair in the form of xy. Alright? The value of x here is just the x-coordinate. We're not done yet. We also have to solve for y. And how to solve for y? We will substitute this x to either of these three equations and solve for the y variable. But the best equation to use is this one because the variable y is already isolated. So, let us substitute. Y is equal to negative 2x and x is equal to 3. And then plus 7. Negative 2 times 3 is negative 6. And negative 6 plus 7 is positive 1. Y is equal to 1. Which means the solution is the point 3, 1. X is 3, y is 1. 3, 1. So, what does this solution actually means? If we try to graph each of the linear equations involved, we can see to it that the lines intersect at the point 3, 1. And the intersection point is the solution. And this type of system of equations, which has a certain point as a solution, is called consistent independent systems. Problem number 2. Let us solve the following system of equations. Again, let me copy. Okay, in this system of equations, take a look in the first equation. We have the variable y already isolated. That's good news because we don't have extra work. The variable y is already isolated and we just have to plug it in into the y variable in the second equation. Okay, so let's do that. We have 3x plus 2 times y, and y is equal to 4x plus 1. Equals 13. The only variable left is variable x. Solve for x. 2 times 4x is 8x, while 2 times 1 is 2, equals 13. Combine like terms, 3 plus 8, that's 11x. And then transpose 2 to the other side and make it negative. 13 minus 2, and 11x is equal to 13 minus 2 is 11. And if we divide both sides by 11, the value of x is equal to positive 1. This is the x-coordinate of our intersection point or solution. Now we have to solve for the variable y. So let's just substitute the value of x here directly. Y is equal to 4 times x. X is 1 plus 1. Y is equal to 4 times 1 is 4. And 4 plus 1 is 5. So y equals 5. Therefore, the solution is the point 1, 5. And if we check by graphing these two equations, we can see to it that the solution is indeed the point 1, 5. And again, the system is consistent, independent. Next problem, solve the following system of equations. Okay, for this system, let's focus on the first equation and isolate the variable y. As you can see, we have a color coordination for the y variable. So we have y is equal to, if we transpose 5x to the other side, it becomes negative 5x, and then we have plus 10. And all we have to do is substitute this y into the y variable of the second equation. So we have 2x minus 3 times y, and y is equal to negative 5x plus 10. So negative 5x plus 10 is equal to 4. Let us solve for x. Negative 3 times negative 5x, that's positive 15x. While negative 3 times 10, that is negative 30. Equals 4. 2x plus 15x is 17x. Transpose negative 30 to the other side. It becomes plus 30. And 4 plus 30 is 34. 17x equals 34. And if we divide both sides by 17, the value of x is 2. So this is the x-coordinate of our solution. Next, we will plug this x value into this equation. We have y equals negative 5x, and x is equal to 2 plus 10. Negative 5 times 2 is negative 10. And negative 10 plus 10 is 0. So y equals 0, which means the solution is the point 2, 0. And we can check this solution by graphing the two lines. And upon checking, it's clear that the solution is indeed the point 2, 0. And again, the system is consistent, independent. Next, let us solve the following system. Okay, let me copy first. Okay, the first equation, this is good because the variable y is already isolated. All we have to do is directly plug it in to the variable y in the second equation. Therefore, we have 4x minus 2 times y, and y is equal to 2x plus 5. Equals 6. Let us solve for the x variable. 4x, negative 2 times 2x is negative 4x. Negative 2 times 5 is negative 10 equals 6. And 4x minus 4x is 0. Okay? So this cancel becomes 0. Therefore, we have negative 10 is equal to 6. However, negative 10 is not equal to 6. So what's going on? What does it mean? Well, it means the system has no solution. What does it mean if the system has no solution? It means the two lines are parallel. So if you try to graph, you'll get something like this. The lines are parallel and they will not intersect. Okay? And since they will not intersect, they will have no solution. And this type of system is called inconsistent system. Now, to prove that these two lines are parallel, just use the slope-intercept form. The first equation is already in slope-intercept form, right? Y equals mx plus b, wherein the slope is 2. So the slope of this line is equal to 2. Now, if you turn this into slope-intercept, you'll get negative 2y equals negative 4x, and then plus 6. Divide both sides by 2, you get y. Rather, divide both sides by negative 2, you get 2x minus 3. And again, the slope is 2. So the slope of the second equation is also 2. And since they have equal slopes, they are indeed parallel lines. Okay? Again, these are the slopes. Next, solve the following system of equations. Again, let me copy. Just like the previous problem, the first equation has the variable y already isolated. So we can just directly plug the y value into the second equation. We have negative 6x plus 2 times the variable y. Y is equal to 3x plus 2. So 3x plus 2 and then equals 4. And let's solve for the variable x. Negative 6x, 2 times 3x, that's 6x. And then 2 times 2 is 4, so plus 4 equals 4. However, negative 6x plus 6x is also 0. Therefore, we're left with 4 is equal to 4. And 4 is equal to 4 is a true statement. So what does it mean? What is the solution? Well, the solution is all real numbers. All real numbers means that these two lines are coinciding with each other. Okay? So they're just like the same line. If this is the graph of one equation, the other equation is also like this. And to prove to you that they are the same line, we will do algebraic calculation or manipulation. So this equation in slope-intercept form is y equals 3x plus 2. And this one, let's turn this into slope-intercept as well. 2y equals transpose negative 6x to the other side. It becomes plus 6x and then plus 4. And if we divide both sides by 2, what do we get? This becomes y equals 6 divided by 2 is 3x, and then 4 divided by 2 is 2. See, they are the same line. Okay, and since they are the same line, they have the same graph. And if they have the same graph, it means all points are solutions. So the solution is all real numbers. And this type of system is called consistent dependent systems.